electric cars make sense, and the focus was making electric cars make more sense. If it's a 2-ton electric car with a 1.5 ton or ton battery, the battery's primary job is moving itself around, as opposed to moving the human around.
The reason why it's a two-seater with one person in front of the other, that's because we found studies showing that the average commute has 1.2 people. So we thought that that makes sense, like having one primary centrally positioned driver that gets most of the attention and gets a nice sort of space to work in.
It's very exciting to see how everything developed from the very beginning, when we had just an idea in a completely unrelated Skype call that I met Lewis. I was in Portugal, he was here in Sweden, and I showed him some of my designs. Everything started developing from there.
We're kind of inspired that humans got so far with laptops and smartphones, and we just wanted to see that experience in a car, where you can step in and you could have that seamless digital experience. And we carry that through with the whole company strategy. So we don't focus so much on the vehicle identification number. Instead, we focus on your digital identity.
My role is to make sure that all the interaction points, the interaction between the driver and the car, that those are safe, fun, and cause as little frustration as possible. It's challenging, but if done right, I think it could have a really powerful impact on the experience of the user.
We managed to build all these 3 cars within 4 months, which is unheard of. And with a team it's insanely small. We're only 15-20 people that are working on the cars, and they're inexperienced and they are all young engineers. Like, I'm one of the old guys and I'm 29 years old.
Usage patterns are different, demands are different, ownership models are changing. There's an opportunity to do something really different, which is what this car is. But that means inherently different means inherently risky. And we have to find ways to minimize that risk. And the best way is to just get tens of thousands of people involved in the process. So that's, for example, why we do crowdfunding. And in the process of designing this, we started with virtual reality. So very primitive, and we just got thousands of people in there to develop the interfaces and see what their reactions were, and build that right up into launching the evaluation prototype. It's one thing for people to help design a cool car that they all love, but will they make a long-term financial commitment to the product and the company? So that's why we went into MediaMarkt and got online to see, will people put money down and wait for 2 years for a car? Like, do they really want to buy it? That had great results. I mean, in the short test, we did 2,500 orders.
What we had to do in the beginning was support the design team, so make sure that what they designed meets the requirements of the customer, but also is physically possible to manufacture, basically. Then when they had the mesh model done of the vehicle, all the physical specifications were basically on paper and we could start applying them. We had so much to do in a very short period of time, and just making sure that everything came together. So that's where tools like Siemens NX is so powerful, because you can work on a whole system together at the same time and everything can lock into place without any trouble, because you're working collaborative. So now we've basically created the concept of the vehicle. Now it's time to start developing all the systems and all the components for the production vehicle. We can basically build a twin of our vehicle for production. We want to use the strengths of the Siemens suite and do all simulation within Siemens, because then you can connect that to any change you do. You can basically update your simulations on the go. Then when we go into production, we want to create a production twin of the vehicle and a production twin of the factory, and then use data when we actually use the vehicle. We can see if something breaks or you have an issue with something. You can track where does that come from within the production, and then improve the twin, but also improve the reality.
The Siemens PLM system is like a whole universe. Imagine how much more lean you can make global production if you have a mother factory and then small satellite factories that are all set up in a digital form first, and you can do cost modeling and check out logistics and simulate everything before you actually do it. And the main reason why we wanted to go with Siemens for this was because, sure, you have MindSphere and you have all this data acquisition backend, but that sort of database and that whole sort of digital backend that Siemens has is also connected to the energy grid globally and the roads globally and the cities globally. It's not just the data we create, it's the net data created by humans that we get to be a part of.